And welcome back. Today we're going to look at the code which I use to form the array that generates the clock face shown here. Hey, thanks for listening to the intro music, and here we are back, and here's the code that drives the wheel, so to speak. So we'll start looking at what we plan to do. So what we want to do is we want every fifth LED to be dimly lit, our hour markers. We want the second hand to be a single LED, a blue one to start with. We want the minutes to be green and to be shown as 3 LEDs with the centre one brighter than the outside two. And the hours I want to be red and they're shown as 7 LEDs with the centre to be bright and both sides reduced in brightness and the outside two reduced further. So sort of dimming to the edges. And as we're going to be driving the array of 60 WS2812b's that are formed into a circle, we want a way to represent this in memory. So the first thing is we create a struct of 3 unsigned integers called red, green and blue, and so that allows us to look at the individual colours contained WS2812b. We want to be able to access the LEDs in an easy way so that we can shift the data out serially. And to do this, what we'd like to have is an array of 180 LEDs or 180 chars or ints and shift through them or iterate through them, sending them out so that we can send out the data serially. And this is an easy way of doing it. We create a struct, or actually we're going to create a type called data_t, and it's going to be a structure. It's going to consist of a union of 60 12812b's called LEDs, so that's 60 of these, and also it's going to have a union of an LED array that is 3 times 60 LEDs, 3 colours in each, 180. So basically we now have 180 bytes referred to by groups of 3 and 180 bytes referred or referenced individually. So in memory it looks a bit like this. There is the struct of a WS2812b. There's the second one, and below it we have the LED array 0, 1, 2, 3, 4, 5, etc. We have 2 ways of getting to that bit of memory or that bit of memory. So we can go LEDs 1.green and set it to 255, and we'll be setting this memory location to 255. We can also look at it as set the LED array number 3, which is this one, to 255. So we've effectively changed the same bit. And this helps because this gives us an easy way to look at the LEDs in the array. This gives us an easy way to serially shift out. And now we also want to imagine the array being circular. Memory array we're thinking of it like that, but we want to think of the two start and finish ends touching. The way that we do that is we need to be able to cross the start and stop boundary for LED 0 and LED 59. And the way we do that is we use a modulus function, a modified one. And so when we have the center LED at position N2, next we want to display how this LED wraps around the circle, because this will give us problems if you think of a linear array with an end and a start, and we need to have a circular buffer. So we modified the mod function to allow the LED position to be calculated with a negative offset. So where we have the center of the position at N2 and we want to light N-4, this modified mod function will bring in -4, and due to the if statement, the result, which will be -4, is less than 0. So we take -4 away from 60, which is passed in as B, and we return the result. And obviously, if n is 2 and we take away -4, we want to light up the second in from the end of the array, and this produces us 58, which is the result we want. And I think I got confused myself saying that. Well, we're going to use a function to update the clock display, and we're going to pass it by reference, and it's called display, and that is just a structure that's being passed to it, which you saw previously. Now, the first thing in the routine we want to do is we want to blank all the LEDs, and we can do this in one or two ways. We can use LEDs n dot color, or we can use the LED array n equals 0, of which you see here. Here we're using the LEDs iterated by I, and we are changing the blue, the red and the green to 0. But then here we've got the LED array, which we're iterating by I, and we're just setting the individual one to 0. As you can see, it's 0 to 59 up here and 0 to 179 here. So we can use either one of these. This one's the easiest one to do, less typing. We obviously want to set these little purple hour indicators, and again we've done that just by going round and setting every fifth LED to a bit of blue and a bit of red. The order we load the data into the array affects how we see the action of the clock. So the data which is written into the array first is overwritten by the next set of data. So we add hours first, followed by minutes, and lastly second. So let's start with the hours. We need to convert the hours of the clock to get the correct position on the display. So 3 o'clock equals 3 modulus 12 times 5 gives us the 15th LED. Say for 9 o'clock, 9 modulus 12 gives us 9, times it by 5 gives us the 45th LED. Now, if we're in a 24-hour format, 2200 hours divided with a modulus of 12 gives us 10, times it by 5, like the 50th LED. And we want to remove magic numbers. Magic numbers are numbers in your code that makes it work, but does not pass on any intelligence or help with debugging. They're just numbers. They don't actually tell you what the programmer was thinking. So here, instead of just putting hours on display as 12, just writing 12, we've got the hash define hours a day 12, number of LEDs per hour 5. So straight away down here, you have an indication of what the actual thing is doing. It's taking the hour information that it's passed to it. It's using the modulus function on that to get a 0 to 11 number, and it's timesing it by the number of LEDs per hour. We would also like the hour hand to move around the clock like an analog clock hour hand does. So for every 12 minutes elapse in the hour, we'll increment the hour hand by 1 LED. And therefore X gives us the center point for the hour hand display. We are going to display the hours as 7 LEDs being lit and the center one being the brightest and dimming down each side of it. We are using the mod function to take the number of LEDs and take the modulus of 60. This function is modified by the mod command that we saw earlier, and this will allow us to wrap around the display. We want the hour indicator LEDs to show through the hour display apart from the center LED. So only that one we set other colors to 0, so we only have a single color, and then we dim down either side of it. We want to light up 3 green LEDs in the ring for the minutes. Again, we want the center one being the brightest and dimming down either side of it. We also want the center of the minute hand to be only green. And so we set again the other colors in the same LED to 0, so only the green is there. On either side, the other lit LEDs will still be functioning. And now we want to light up a single blue LED in the ring for the seconds. Again, we also want the LED to light bright and a single color. So again, we set the blue to full brightness and the green and the red are off, so it's only blue. And that just leaves us to call the routine that sends the data to the display. And as the routine to drive LED uses the LED array to send the information out serially, we just pass the LED array to that function shown here. Now, that's probably a bit long and boring, but that's how I set up the array to show hours and minutes. Next video might be on how to use the real-time operating system drive the LEDs. So if you like if you're stuck with me and you like what you see, and you're not subscribed, please hit the subscribe button. Please hit the notification bell, and I'll see you on the next one. Plus, comment the hell out down below. Comment. I'll answer everyone I can. Tell me if I'm wrong. Tell me if I'm right. Tell me if you didn't like it. Catch you on the next one.